And we're back, and we are looking at thin-walled cross-sections and torsion, and we have a symmetric tube from a high-strength steel having the mean dimensions shown. I always like that because it's already telling me those center line dimensions. We have a thickness of 5 millimeters. It is subjected to a torque of 40 Newton meters. Determine the average shear stress developed in points A and B. Indicate the shear stress on a volume. Also determine the angle of twist if the tube is 2 meters long. So if we are dealing with thin-walled structures, then I know that my shear force average is T divided by 2 thickness area mean, and my angle of twist is TL divided by 4 area mean squared, our shear modulus, our perimeter divided by thickness. Okay, so what do we know? We want to determine the shear stress. We are given a torque. So our torque is 40 Newton meters. Our thickness is 0.005 meters. Our length is 2 meters. It is mean dimensions, also determine the angle of twist, high strength steel. So we would have to calculate G, and we could get G from the back of the book. And we'll get that value in just a minute. And then we want to determine the angle twist. Okay, so the first thing I need to do is determine my area mean. So the nice thing is it gave us all center line dimensions. So we're just going to kind of make this, and we're going to kind of assume that it kind of looks like what we were given. Okay, and I know that this right here is 40 millimeters. I know from the top, okay, this is 40. I know that this is 60 millimeters. This is 60 millimeters. And if it is symmetric, we are at 60 millimeters and 60 millimeters. So so this has to be 40 millimeters and 40 millimeters. So I could divide this up, and I'm going to look at, here is a square, and well, I guess they're rectangles, rectangles, rectangles. And these are going to be rectangles of 60 millimeters by 40 millimeters, and I have 4 of these. 1, 2, 3, 4. Now I can go back, and I still have this area in the middle, and it is a nice square. So we have a square, and its dimensions are 40 by 40, and I have 1 of those. So now when I'm calculating my area mean, I have a really easy way to see what is going on. So my shear stress equals torque. So I have 40 Newton meters divided by 2 times my thickness, 0.005 meters, area mean. So I have 4 times 0.06 times 0.04 plus 0.04 times 0.04, and that gives me my area. So I have 40, 2 divided by 0.005 divided by 4, enter, 0.06 times, 0.04 times, 0.04 enter, 0.04 times, plus divided by. I have a shear stress of 1, 2, 3, 4, 5, 6, 0.357 megapascal, which clearly that's going to be less than yielding. And now, if we wanted to find that angle of twist, TL4 area mean squared G, funky thing, ds divided by t. So I need to go back and figure out my perimeter. Let's choose a different color here. So my perimeter is actually this part that goes around. So I have 1, okay, and then 2, 3, 4. So when I'm looking at that perimeter, 60, 40, 60 times 4, okay? Because I have 4 of those sets. 40 Newton meters times 2 meters divided by 4 times. And let's just go ahead and calculate that number. 4 enter 0.06 times, 0.04 times, 0.04 enter 0.04 times, plus. So that area mean is 0.0112 meters to the fourth. And we are going to square that. G, I haven't looked that up yet. And then I'm going to have 4 times, okay, 0.06 plus 0.04 plus 0.06 divided by my thickness of 0.005. So we're not going to worry about G right now. We have 40 enter 2 times 4 divided by 0.0112 enter squared divided by, don't worry about G yet, okay? And then we have 4 enter 0.06 enter 0.04 plus 0.06 plus 4 times divided by thickness times, and I'm going to get this very large number, 2040863 divided by G. And usually G is in gigapascals. Is that right? Mega, giga. It's going to be divided by something by 10 to the 9th. So we could just even say like 2e to the 9th divided by, and we get this nice little 0.001 radians. So anyways, that's how we would find, I just made up a number of 2 times e to the 9th because you know it's going to be e to the 9th if we're in those units. And that's how you would find the angle of twist.